Now we are going to solve the numerical problem number 5.1, which is given in page number 270. It's a very interesting problem. I would like to discuss the problem in a very serious manner because the formula which is required to solve the problem is not given in the textbook. First we have to derive, only then we are able to solve. First I will explain the problem. One parallel plate capacitor is given. The parallel plate capacitor, it is connected with the AC source. The RMS value of the voltage of the AC is given 230 volt and the frequency of the AC is also given 50 hertz. The distance between the plate is 1 millimeter, that is converted into meter, 1 into 10 to the power of -3 meter, and the area of the plate is 20 centimeter square. Both are having same area, and the 20 centimeter square value also converted into meter square, 20 into 10 to the power of -4 meter square. Here you are asked to find out the displacement current which flows in this region, okay, when the time is t is equal to 1 second. So all data are given. Here I have written all required formulae. Without knowing the required formulae, we can't solve. First you should know V is equal to Vm sin omega t. Already you have learned this formula in 4th chapter. And maximum voltage is also equal to Vrms into root 2. Omega formula is also already known. Omega is equal to 2 pi into F. And electric flux is equal to electric field into area. This formula is also already known. Displacement current formula is epsilon naught into d pi e divided by dt. Rate of change of electric flux into epsilon naught is id, and electric field is equal to v by d, and cos 100 pi value must be known, that is equal to 1. So by knowing all the formulae and data, we are going to calculate the value of id. Okay, first we'll write the equation. This equation to be written in proper form, v must be known. How to calculate V? That is a question now. So first we will write the formula for V. Are you clear? So what is V? Instantaneous voltage. V is equal to Vm sin omega t. So this is the formula to calculate V. V is equal to, Vm formula is Vrms root 2 sin, instead of omega we can write 2 pi f into t. This is a formula. The next step we can write Vrms value is already given, 230 into root 2 sin 2 pi. Here instead of f we can write 2 pi into 50 into t. The next step we can write the 230 to be multiplied with root 2. Are you clear? 230 must be multiplied with root 2. If 230 is multiplied with root 2, you will get, that must be calculated by calculator. Okay, 230 into 1.414, its value is 325, approximately 325 volt. Sin of 100 pi into t. So V is found out. V is ready. Are you clear? Next we are going to use this V. Is it clear here? Are you clear? In this formula we have to use this V. That's why this equation should be kept ready. Are you clear? The next step is id. id is nothing but displacement current. Okay. Now we are going to get the formula for id. How to get the formula? id is equal to epsilon naught of d pi e by dt is the formula. The next step we can write epsilon naught d by dt of, instead of pi e you can substitute EA. Okay, so here that A is a constant, that A can be written here, epsilon naught A dE by dt can be written. Again, that E can be replaced by V by D. The next step, we can write epsilon naught A. The D is constant. Therefore, D can be combined along with this factor. So, V alone will change. So, we can write dV by dt. So, finally, to calculate ID, this is the required formula. Are you clear? So, I will write the formula now. ID is equal to epsilon naught A divided by D dV by dt is the formula. So, here the value of V is already found out. Already it is written here. That must be written here. Okay. Now, I will write the factor epsilon naught A divided by D can be written separately. D by dt of, instead of V, we can write this expression. This which expression? This expression should be written 325 sin 100 pi into t can be written. So, instead of V, is clear, this entire expression must be written. Are you clear? Now, the next step, the 325 is a constant that can be brought in this side. Epsilon naught A divided by D, that number 325 that can be brought out, and this factor alone to be differentiated. Which factor? Sin 100 pi omega t to be differentiated. Are you clear? If sin 100 pi omega t alone differentiated, you will get cos 100 pi t you will get. Understood? Again, this omega t to be differentiated. If omega t is differentiated, you will get omega. So, which part is omega? 100 pi is the omega. Again, you will get 100 pi. So, this is the final one. Are you clear? So, now we have got a final expression. In this expression, instead of t, 1 second must be substituted and rest of the constants must be substituted. You will get the answer. Understood? Now, we have to substitute the required values in the formula. ID is equal to, epsilon naught value is 8.85 into 10 to the power of minus 12, and then area of the plate is 20 into 10 to the power of minus 4 into 325. Here cos 100 pi is there. Cos 100 pi, instead of t, you are asked to calculate the displacement current at 1 second. Therefore, t to be replaced by 1 into remaining value is how much? 100 pi. So, the factors, everything is written. Okay. Now, we have to write the denominator. In the denominator, the distance between the plate is there. So, draw the line and then write the denominator. D value is, distance between the plate is 1 into 10 to the power of minus 3. Now, we have to simplify certain factors. Cos 100 pi value is 1. Again, you write 8.85. You bring all the numbers together. 8.85 into 20 into 325 into cos 100 pi value is 1, and then 100 into pi can be written as 3.14. Okay, and then later we'll write all power factors. Here in the denominator 1 is there. Now we'll write all the power factors that should be brought up. 10 to the power of minus 12 already there. 10 to the power of minus 4 is there. Okay, and then one more factor is 10 to the power of minus 3 if it is brought up, that one becomes plus 3. So, all the factors are written and we have to calculate the final answer with the help of calculator. If all the factors are multiplied, if all numerals are multiplied, you will get the answer as, now this is not required, already we have copied. So, therefore, the bottom one need not be written here. So the multiplied value, if all the factors are multiplied, you will get 180,710,14. Already I have calculated this entire thing by using calculator. Okay. So the remaining thing is 10 to the power of minus 12, 10 to the power of minus 4, 10 to the power of plus 3. If everything is simplified, you will get 10 to the power of minus 13. Now this 10 to the power of minus 13 can be written as 10 to the power of minus 7 into 10 to the power of minus 6. By using this 10 to the power of minus 7, we can displace the decimal point 1, 2, 3, 4, 5, 6, 7. Therefore, we can write 1.08. This decimal point can be brought from here to there. So, we will get 1.8. What is the remaining one? 10 to the power of minus 6 is there. Ampere. That is the value of displacement current, ID. This one can be simply written as 1.8. 10 to the power of minus 6 can be simply written as microampere. So, this is the value of displacement current. That one flows in this space. Are you clear? That is ID. Are you clear? Due to the change in flux, due to the variation in the electric field, a kind of current that is passing, is it clear? Without any, in this space, is it clear? Free space, no, in this region, certain amount of current is flowing due to the variation in the electric flux, due to the variation in the electric field. So clear, such current is called, what is this? ID. That value is found out here. Very interesting problem. Work out the problem. May be asked in 3 mark. Okay, thank you.